heating and air conditioning, or HVAC, pertinent to residential use, and how a contactor works in the condenser for residential use. What are the pros, etc., and then what makes it work, what makes it come on, what makes it come off. So to the left we have an HVAC contactor here. Okay, to the right we have a light switch. I'm not sure if this is good. This may be a three-way switch. It may not be just a standard. This may have the black and this and that, but those familiar with electricity kind of know what I'm talking about. But notwithstanding, this is just for illustration purposes only. But again, we normally if everything's wired properly, we may have voltage here, and no voltage here until down here on the sides we have the low voltage. Once the low voltage becomes energized, then this pulls in here. So then this would open the circuit. So basically, we can kind of think of it, say hypothetically, if the okay, when the low voltage energizes this, okay. So if we go over here to the light switch and we take this light switch and then we technically just flip the light switch to the up position where the electricity, hypothetically, again, this is only for illustrative purposes only, now the electricity can flow throughout the system from the line side to the load side. So once this is energized, this actually would be like doing this manually. You would take your hand and flip the switch to allow the electricity to flow. Otherwise, it breaks the electricity here. But over here, this would be done electronically via low voltage. So once the low voltage energizes here, it pulls in here. So essentially what it does when we pull in here, when we pull the contactor in, it makes contact with this. And it's kind of like, if you look to the right where we threw it up to allow the electricity, it's kind of like the same thing. It's basically like a cut-on, cut-off switch. So now we've energized the low voltage, which is on the left and the right down here, pulls this in, and it's kind of similar, analogous to the switch that we flipped it up, flipped it on to allow the electricity to flow through. So in this particular case then, we see, okay, the light switch here is manually. One would grab it by their hand or just put their fingers there, flip it up, allows it to go. Well, this contactor kind of acts like the same thing. You're trying to get voltage instead of here to here, you're getting voltage from here to here. But in order to do so, it must be energized here, and then it energizes the coil, the 24 volts, and pulls this in. So then when we pull this in, it would be kind of analogous to flipping the switch there, so the electricity can go from the bottom to the top, etc. And then same thing here. So now if we go over here and the light's on, say we have this attached to a light, this is a three-way switch, so just this is only for illustration. And so we flip the light switch off. Now the light switch is off. So the contactor is running and the contactor is energized. And so what happens is when the contactor is energized, the low voltage energizes it, so it actually gets the coil and it pulls this in. So the electricity's flowing. Now the thermostat needs to reach, once it reaches the set point, say if you have it set to 70 degrees and it becomes 70 degrees and the unit cuts off, or if you just hypothetically just turn the thermostat off, then what happens, the left and the right is de-energized. Once it's de-energized, then this pops up and the electricity stops on one side. So, and like here, if we actually flip the switch manually. So what would be the difference? This is just an illustrative fictitious scenario here. So no electricity here. We have electricity on the bottom, but not on top. When this is de-energized, it's the same thing. But the difference is we do this one by hand, and this one's done by it cuts. We cut the voltage here by hand. This voltage is cut by low voltage on the side on the left and the right, perhaps, and then this either turns on or turns off. So the only difference is one is manual, flipping it this. So if we flip this on, bam, that's flipped on. So that now the light switch would be on. Say if we had a ceiling fan or whatever, say hypothetically it would be on. Now if we need to try to cool the room, so it calls for cool. This is energized, and now this pulls in, and now the voltage is on the top and the bottom. So basically they're just like cut on, cut off switches. It's nothing overly complicated, but once you begin to understand, one begins to comprehend in a no nonsense type of way. And basically, so a contactor could be used to cut on and off. And if you don't cut it off, if it's stuck, your compressor and condenser fan motor will continuously and incessantly run. Hence, it may burn it up over a period of time. Now, I guess you can leave this switch on, and it depends on what you're doing, how long the light will last, who knows. But so this one is done by hand, and this one is done by low voltage electricity, allowing the high voltage to go through. Thank you for watching. Have a great day.